how to find capacitance of a capacitor? Means, if I have a capacitor, then generally we find a capacitance written on the capacitor. I have a capacitor, okay, and it's written, it is 1000 microfarad, okay. Now, we are going to do all the calculations in our electronic circuit, considering 1000 microfarad, and certainly there will be kind of many loopholes when it is not 1000 microfarad. Now, how I can measure the actual capacitance of a capacitor? Okay, so I need not buy a costly CRT oscilloscope or function generators and those kind of things. Okay, and means then how I can find the actual capacitance of this capacitor? Okay, so we will see that we will use calculus. Calculus is a kind of mathematics way to do some computation. So we will use a calculus, and we will use simple multimeter. Simple multimeter in the sense the most basic multimeter, means anyone can purchase in kind of very limited money. So multimeter would kind of measure current, and then we will use the calculus technology to kind of mathematical way to calculate the capacitance. Okay, so if there is some deviation like 1%, 2%, up to 5%, then it is alright. Otherwise, it is not tolerable that if it has large deviation. So, what we are going to do now? So, we will take a kind of RC circuit. RC circuit in the sense we will connect a resistance in parallel in a series to the capacitance, and then we will let it charge capacitance, and depending upon the charging time, okay, then we will come up with the formula through calculus, and then theoretically we will know that how much time it should take. If I have 1000 microfarad capacitor, and if I know the resistance that is connected in series, then theoretically how much time it should take to charge. Means I know various property of capacitor, like if I know the strength of this capacitor, that is capacitance, then how much charge it would be storing kind of time to time if I apply a certain voltage across it, or how much would be the current at any moment if I know the kind of permanent voltage, I mean the DC voltage that is behind the scene. If I know the value, then how much, because current would vary, the resistance of the capacitor changes kind of is depend upon how much charge it is stored. So it's a net resistance, means electronics is a game of resistance only. So if I have a voltage and then current would flow. Now I have many paths where the current would flow, like I have a voltage source and I have positive and negative, and between that I have many paths through which current can flow from positive to negative. Then how much current each path would take, that depends upon how much resistance that path is showing to the voltage. So it's a game of resistance. So voltage source, it doesn't know that it is in phase or it is not in phase, and how much angle deviation this side and that side, and what is the di by dt, and what is dq by dt, and what is d square I by dt, and what is dt square, and what is the charge storage at this moment and that moment, and what is the independent variable and independent variable. A voltage source only know how much resistance someone is showing in its path. So if the other path is showing less resistance, then more current it would flow in that direction, less current it would flow in this direction. Okay, so how much this capacitor is at the end, it is showing the resistance to the voltage source. So that resistance is variable. It's not like any resistor where resistance is constant. So more charges, more charge it is storing, it will show more resistance. It is empty, then it will show no resistance. Okay, means it will say I need current because I need to store the energy. So we'll see that if I know the characteristic that how charge, voltage, and capacitance are interrelated to each other, then as per its resistance is changing time to time, will come up with calculus, will come up with a formula that at any moment what would be the current. Okay, if I know the voltage, if I know the resistance in the past, actually we calculate the resistance at any moment indirectly. If I know resistance of this at any moment, then I can know that is it RC circuit, so other resistance anyway I know. So I know that how much current would flow, but technically we'll calculate the current at any moment. So if this is X, then at that time instance, what would be the current? Okay, and then we will try. Then we have kind of sum. Then through formula, we will try to find out that it should meet some criteria. If it is 10,000 microfarad, if it is not meeting, then what is the actual capacitance? Once we know the actual capacitance, then based upon the actual capacitance, we will draw a graph that at what this time what would be the current, and we will measure whatever measurement we have done, and whatever the measurement we will get through calculus. Okay, then we will draw both, and it should coincide. Okay, if it coincide, then we are sure that whatever the capacitance we are finding through practical way, that is correct, and it is crucial. Means if there is a variation, less variation is there, then there is no problem. But if capacitor is showing large variation from the value it is written, then it makes sense to calculate the capacitance. Okay, so that we'll see measuring through calculus and simple multimeter. Okay, so we have taken a capacitor. This is a kind of 1000 microfarad capacitor it is, and we have taken one resistor. I think it should be visible. So a resistor is around 56 kilo ohm. I believe we can measure it. Okay, so first we'll see how much is voltage. So we have taken a battery source. So the voltage across battery source will measure. Okay, it is 2.6, and capacitor should be reset. No voltage, and we will measure the resistance. Okay, so it is 56 kilo ohm resistance. Okay, so we'll connect it. Okay, so we have finished the connection. So now I'll attach the battery, and then we'll see the change in current. Current should be, it should become 1 or 0. It would take some time because capacitor is powerful. It started with around 46. Okay, minus we are showing it is like ammeter is connected wrongly. Okay, so it has reached 11. We'll wait till it becomes kind of 1. It will take some time. Okay, so beginning was quick, and that is the kind of capacitance behavior, capacitor behavior. But reaching a kind of 0, it would really take time. Okay, so it reached 1, so I think we can stop it, and this is the kind of time duration it took. This is what we'll consider, or we'll wait till it will flip for 0. Okay, so I think it's enough. So we'll disconnect it, and we'll measure the voltage across. Okay, so it is flipping, so I think we are done. So we'll measure the voltage across the capacitor if it is really charged. So white is positive and blue is negative. Okay, it is really charged and it is discharging to 0.5352. Okay, this is the rate of discharge. Okay, so it will discharge slowly. Okay, so that is about the kind of a capacitor behavior. Okay, so how much charge stored at any point? So that is integration of the current. So if I try to write like this, Q equal to, so that will be integration of the current over the time, I dt. Okay, so this is the scenario here. And this is very important. So the charge stored at any moment. Okay, so charge stored at any moment is integration of I dt. So, or current at any moment is dq by dt. How much charge is getting stored? So, what is the diff in that? So, dq by dt. Okay. So, now if so all three vehicles. So, if dq by dt is I, then I at any moment is c into dv by dt. Now, as we talked that if I kind of integration is nothing but calculating the area. If I have a curve whose equation is I, and then I calculate the area, it becomes Q like that. So if this is the curve, we can see this yellow. This is the curve of I. So if I calculate this area, okay, if this is the curve of I, then integration, if I calculate the area, this area, so if we have a kind of close watch, then this area, here it is less, slowly it is growing, okay, and area is maximum here, complete. This area curve, if I draw, that is Q. You can see area curve is growing. This is area curve, okay, and after a time it becomes stagnant. So this is Q. This is area curve, and this is the area. This is I curve. So if I know I curve, I calculate the area. That area is this curve. It starts from 0 and it proceeds like this. So this is integration. So if I have a kind of a voltage source, current, and it is a CR circuit or C circuit, then I have Q equal to CV. And if I have voltage source, then it is resistance voltage and capacitance voltage. If IT is the current flowing at any time T, then R into IT and QT by C. We proceed, and finally we come to a stage where dt equal to CR by dq. Okay. Now we come to another stage where dt by CR. Okay. Now we have CVS minus QT. Okay. So this is a kind of differential equation. So if I consider CVS minus QT as U, then dq equal to minus du. So finally we come to a equation where dt by CR equal to du by U. Now can we see there are two equations. One equation is dt. dt means dt is a variable. So here the constant is minus 1 by CR. 1 is missing here. So minus 1 by CR. So I am doing integration of minus 1 by CR dt over the time tt. So we are calculating area of a constant. Means time is constant. And here we are calculating area of the U. U is variable where means it is dependent upon capacitance. Voltage across the capacitance. If I see the U closely. So voltage across capacitance is variable and this is the variable. Now if I calculate the area of this, means I get the time and then calculate the area of this, then I get like this, and finally it comes to a kind of equation like voltage across the capacitor at any moment is like this, and T is at any time T CR. Okay, so this is the differential equation. Means we started with this and then like Ri. So Ri at any moment is dq by dt and qt by c anyway we have. Now we just shifting left and right. Okay. So dt, now we have two variable dt and dq. So left right we do and we reach here. Then we kind of, if I see this, okay, two variables there dt and dq. dq is changing. At every moment the charge storage is changing. T is changing. Every moment means moment is changing. And charge stored there is changing. That leads to this kind of equation. So 2 u, 1 by x, it will lead to ln. Okay, if I differentiate ln, it will lead to 1 by u. And then finally, ln minus means division, and then if I reverse the ln left side, it becomes exponential, and finally it comes to equation like this. If this is the equation, then current is, okay, if this is the equation, then current is differentiation, and it leads to equation like this: IT equal to Vs by R e to the power Vs by R e to the power T into CR. Now, if time is 5 multiplied by CR, it leads to Vs by R 1 by 48, that is 0. Means this is called tau. CR is called tau or time constant. Time constant in the sense at 5 into CR, 5 into time constant. So can we see the graph? This is the graph is drawn based upon whatever we see, like 1000 microfarad capacitor we have taken, and then 2.6 volt battery we have taken. And if this is the scenario, we add the ammeter like this. If this is the scenario, then this would be the graph. So it starts from 0, and then around 210 it reaches the kind of a stagnant value. So we can say that 210 is the time when it becomes like 0. That time is nothing but 5 into time constant. So if I see this equation closely, so if I keep growing the t, if it becomes 5c into r, then it is almost 0. So that is called time constant. It helps in finding the value of capacity. Anyways, so now we have done the experiment. So we have done the experiment, and this is the lab session, and we can see this capacitor is connected to resistor in series. Then in series ammeter is connected, so multimeter behaving like ammeter. Knob is on microampere, and then ammeter is connected to battery, and then battery finally it is connected here. So in this circuit we went ahead and we calculated the current at in the reading, like initially it is fluctuating, and then 46, 45, and these are the microampere that is appearing, and these are the time instance at which this microampere is appearing. And then like this, then we see that 11, so it started with around 46 microampere, and then it reaching 11 microampere at 1 minute. 46 to 11 in 1 minute, and then 0 in 210 seconds, that is 3 minutes 30 seconds. So that much delay it is taking. So now if I see the I formula, this is like this. So we can set up Vs is 2.6, 56 kilo ohm exponential minus t, 1 into 56 kilo ohm and 1 milli kind of farad. So it comes to 1 into 56. So our calculation is, or now we know that 5 into RC is total time it takes to become current as 0. So 210. So capacitance, it is written 1000 microfarad, but we measure it as 750 micro. But anyways, this is the kind of code we have written in Python, and these are the readings so we have kind of used in a tuple. And then this is a theoretical Y, and then this is a practical Y, that is the kind of second element of that each tuple, and we plotted like this. So red color is the experimental one, what we got, and it is theoretical. So obviously it is different because we thought it is 1000. Probably we can try with 750 and we see how close it is. We have the program. So here we have used 1. Now we'll use 7.50. And we'll try drawing it again. It is exactly same. It is exactly same. Okay, so our calculation is perfect. Okay, so integration is perfect. Means the way we thought about the integration, and this is the crucial point when we calculate the area, calculating the net charge, and then this is the graph we drew considering whatever is written on the kind of the capacitance. So capacitance, it is written as 1000 microfarad as per the capacitance. This is what we got. But if I change it, then we get exactly like this. It is exactly like unbelievable. Okay, so I mean we can paste it. Okay, so we'll save it. Call like figure 3 and we'll import it. Can someone believe this? Okay, so I can point it that with this graph a theoretical was made. Okay, so theoretical was made like theoretical 1000 microfarad. So theoretical was taken as 1000 microfarad. And I would rather say capacitance, capacitor. Okay, so when capacitance is 1, now in calculation now it is taken as 70 microfarad and they just coincide. So theoretically 750 and practically so, means this is amazing. Okay, so 1000 as per the kind of written on the capacitor, and what we believed it is 750 and it is same. Theoretical and practical is exactly same, means unbelievable.